Okay, so we're on 4.5, part 3, integration by substitution. Now these questions are going to get a little bit trickier today. So let's start right out with number 1, but same concept as that we've done already for parts 1 and part 2. So first thing we want to do is pick a u. So for number 1, I'm going to pick my u as the inside part here, x squared plus 1. Now up here in the box is just our theorem. I forgot to say that when we started out. So again, you're finding your inside part, you're transferring it into u, and then all this means is that you're then going to evaluate. So back to number 1. Du is 2x dx. So for this one, I need to add in a 2 and take out a 1/2. So I'm going to rewrite 1/2 times the integral. Now this is a definite integral, so I'm going to put the boundaries in, and I'm going to rewrite it in terms of u. So my 2x dx is my du. I'm going to put that at the end. And then I have u to the 3rd power. Okay, so next step, I'm going to take the integral. So I'm going to bring down this 1/2, and I'm going to take the integral, so I'm going to add 1 and divide. That's 1/4 u to the 4th. Now I don't need a plus c because we're going to be evaluating when we're done. Okay, I'm going to distribute this 1/2, so that's 1/8, and I'm going to plug back in for u, so x squared plus 1 to the 4th power. And again, we're evaluating from 0 to 1. So last step, and this is the newest step, but we're kind of combining an old topic from part 4.4 where we did definite integrals. We do top minus bottom. So top, I'm going to plug the 1 in first. So 1/8 times 1 squared plus 1 to the 4th power. And then minus, I'm going to plug in the 0 next. So that would be 1/8 times 0 squared plus 1 to the 4th power. So all we're going to do is evaluate both separately. So this would give me 1 plus 1, so 2 to the 4th power, which is 16, and then 1/8 times 16 is 2. And then minus, this would give me 1. 1 times 1/8 is 1/8. So we can write that as 1 7/8. Or we can write that as 15/8. Okay, so let's go on to number 2. So number 2, right away I see a radical. So first thing we always do when we see a radical is we rewrite it. And this is pretty complicated, so I know it's not a question where I'm just going to work from left to right. This has to be a u substitution. So I'm going to let u equal 2x minus 1, the inside part here. So du is going to equal 2 dx. Okay, so I don't have a 2 dx, I just have an x dx. So I'm going to add in the 2 and take out the 1/2. The only issue that I have in this one, this is like the difficult question from part 2, is I have an extra x in the problem. So I'm going to right away just go ahead and rewrite my problem with what I have now. 1/2 integral 1 to 5. Draw a line here so we don't get these two questions confused. X over u to the 1/2 du. So again, I have an issue here because I have an extra x in the problem and I only want one variable. I don't want to work with two variables. So on part 2, what we did is we took this u equation and we solved it for x. So if I solve this equation for x, I would add 1 and divide by 2. And I can use that information to plug in over here. U plus 1 over 2 divided by u to the 1/2. So I'm going to do a little bit of algebra work to clean this up. I'm going to move this u to the 1/2 up to the top by making it u to the negative 1/2. I'm also going to move this 2 to the outside, so that's going to give me 1/4. Okay, so next thing I'm going to do is distribute u to the negative 1/2 times u to the first. We add exponents when we multiply, so that gives me 1/2 plus u to the negative 1/2 du. So I'm finally ready to take my integral. So I'm going to keep bringing down this 1/4. I'm going to add and divide, so that would be 2/3 u to the 3/2 plus 2 u to the 1/2, and we're evaluating from 1 to 5. Now, before I go and plug in, I'm going to plug back in for u. I'm also going to distribute this 1/4, so hopefully the math becomes a little easier. 2/3 times 1/4 is 1/6. U is 2x minus 1. 2 times 1/4 is 1/2. Plug back in for u, 2x minus 1. And we're going from 1 to 5. Okay, so here's where all the work comes in with the calculator. So I would use your calculator for this problem because you've got a lot to plug in. We got to do top minus bottom. So I'm going to come down here. I'm going to plug in the 5 first. Now if I plug 5 in here, that gives me 9. Same for this. I'm going to switch colors so we can keep track of what we're doing here. Minus. Now I'm going to plug the 1 in. So 1/6. If I plug 1 in here, that gives me 1. So we're going to do the red minus the purple. And you might want to pause it right now. Go ahead and see if you can figure that out. You can plug it all in at once on your calculator if you want. But overall, that should equal 16/3. Now remember, anytime you want to check your final answer on your calculator, if you have a TI-84, you're going to go to Math and then Function Integral. And you just type the original problem in exactly how you see it. Okay, so let's go to the back. And let's look at question number 3. This one's get a little easier on the back. Okay, so question number 3. One thing I could do, this one isn't so bad. I could actually just distribute this. This gives me x to the 4th plus x squared dx. I don't have to do a u substitution here. So I'm going to add and divide, so that's 1/5 x to the 5th plus 1/3 x to the 3rd. And we're evaluating this from -2 to 2. Okay, so top minus bottom. I'm going to plug in the 2 first. Minus, then I'm going to plug in the -2. So again, you might want to pause at this point and Then you can check your work when you're ready. Okay, so for this one, you should get 272 over 15. Okay, moving on to number 4. So number 4, I could cube this and distribute, but that's going to be a lot of work. So this is going to be a u substitution. So I'm going to start with my inside part. I'm going to set u equal to x squared plus 1. du would be 2x dx. I have an x dx, but I need to add in a 2 so I can have a 2x dx. But if I add in a 2, remember we have to balance out with a 1/2 on the outside. Again, we're not changing the problem, it's still 1, but it fixes it so we have a 2 in there. Okay, so now I'm going to rewrite my problem. So I've got 1/2, the integral from -2 to 2. And what's left would be u to the 3rd du. Okay, so I'm going to bring down my 1/2. I'm going to take the integral, 1/4 u to the 4th. And we're going to evaluate this from -2 to 2. I'm going to distribute here, so that's 1/8. And I'm going to plug back in for u, x squared plus 1 to the 4th. Okay, so now we're ready to do our top minus bottom. So I'm going to plug the 2 in first. 2 squared plus 1 to the 4th power minus, now I'm going to plug in the -2. Now we're going to solve. So 2 squared is 4 plus 1 is 5 to the 4th power divided by 8. So go ahead and pause it. And you can check your answer here in a minute, but let's see, we've got 5 to the 4th power divided by 8 gives me 78.125 minus, now over here, I also get 5 to the 4th power divided by 8, so I get the same answer back. So for this one, our final answer is 0. Now, why this works, if you were to graph this function, the original, the x times x squared plus 1 to the 3rd power, it's a cube function, looks like this, and we would be going from -2 to 2. So if we look at the shaded region here, right here, we have a negative area. And right here, we have the same size, but a positive area. So that's why we got 0. This region here, 78.125, that's the negative area. And this is positive 78.125. When we go to add those areas together, that's why our answer is 0. So one thing to do to check your work, you can always graph the function and see if it makes sense. You can also find an integral from your graph. You go to second trace to get to calculate, and you'll see there's an integral option right there. You just have to give it the boundaries. So you would tell the starting point and you would tell the ending point and then press enter. So that's something you can practice. Now you can go back through and check all of your answers on your calculator to make sure that you know how to do it on your calculator. Okay, so that concludes part 3. Feel free to go back and rewatch any of the questions that you might have struggled with, especially number 2. That was definitely a challenging question.